Good day, viewers. Welcome to ReadyMath Hub. So we have this question here, which was sent by one of our followers. So we are given that the value of A is log of 18 to base 12, and the value of B is log of 54 to base 24. So using that value of A and B, we have to find the value of AB plus 5 into A minus B. So let's get right into the solution. So this is how you're going to approach the question. So you have this is the first thing to do. Okay, so we have A is equals to log to base 12 of 18. So we're going to take it one by one. While the other part is B is equals to log of 54 to base 24. Okay, so we need to convert to index form. Okay, I don't want to solve it at the same time, but let's solve for A first, then we'll do for B later. Now, to get the value of A, now we need to convert to index form. So that's the first step. So convert to index form. So we have A is equals to log 18. Now you have 12 raised to power A. Okay, not 12 times A, but 12 raised to power A. So we have 12. This 12 will raise this A up. So you have 12 raised to power A. Then the log will disappear. So what you're going to have is just 18. Then from this point, you need to break down both sides to their factors. So you break down 12 and 18 to their factors. So 12 is 4 times 3. That's 2 times 2 times 3. So right here you write 2 times 2 times 3. Then raised to power x is equals to. Then 18 is 6 times 3. And 6 is 2 times 3. So that will be 2 times 3. This is 6. Then times another 3. Okay. Now from here, from the law of indices, when you have A, B raised to power 2, it's the same thing as writing this 2 affects this A and this 2 affects this B. So it's the same thing as writing A squared B squared. Okay, so that's the idea I'm going to use here. Okay, now if you employ that idea here, this A affects this 2, this A affects this 2, this A affects this 3. So it becomes 2 raised to power A times 2 raised to power A times 3 raised to power A. Then this right hand side, you have 3 appearing 2 times here, that's 3 squared. So you have 2 times 3 raised to power 2. Okay. Then use law of indices here. In indices, when you are multiplying, that's times. When you are multiplying, that's addition. Okay. And the base is the same, 2, 2. So what you're going to do is just pick one of them and you add the powers. So this will be 2 raised to power 2A. Then times, here you have 3 raised to power A. Then here you have 2 times 3 raised to power 2. Then you need to bring both sides together. Okay, you have to make the right hand side equals to 1. Everything here on this right hand side should be equals to 1. So you need to divide both sides by 2 times 3 raised to power 2. You come right here and do the same thing, 2 times 3 raised to power 2. So if you do that, everything on this right hand side becomes 1. Okay, because you are dividing by the same value. So everything here gives you 1. So everything here cancels out. Okay, then on the right hand side, don't forget in indices division is equals to minus. Okay, division is the same thing as minus. So here you are dividing. The power of these 2 here is raised to power 1. Don't forget, when you have a single number, the power is raised to power 1. Then the power of this 3 is raised to power 2. The power of this 3 is raised to power A. So this is division in the middle. So as far as you are dividing, you have to subtract the powers, and the bases are the same. This is 2, this is 2, this is 3, this is 3. So you just subtract the powers. Okay, now this is what you're going to do. So if you subtract the powers, you have 2, this one 2 raised to power 2A minus 1, that's the power of this one, times, then you have 3 raised to power, the power is A, minus the power of this one minus 2. Then everything should be equals to 1. Okay, now this value, you just leave it the way it is. Come back to it later. Okay, let me just rewrite it to make it a bit neater. Okay, so we have 2 raised to the power 2a minus 1 times 3 raised to the power a minus 2 is equals to 1. So we'll come back to this value later. Let's leave it the way it is. Now let's go back to the other aspect, the other type. You know, there's b. This is for a. Now pick the one for b out. This is b. Now let's solve for b. Now if we solve for b, the same approach, okay, you convert to index form. So to index form, that's the first thing. Now if we go to index form, 24, we raise this b up. Please, not 24 times b, that's wrong. It should be 24 raised to the power b. You should raise it up. So you have 24 raised to the power b equals to, then log will disappear. You have only 54 here. Then from this point, break 24 to its factors. 24 is 6 times 4. Okay, and 6 is 2 times 3. Or just write 6 times 4 to make it easy for you. Raised to the power b. 54 is 9 times 6. Okay, now let's go down. Hope you are following. Okay, it's very, very simple. Now let's break down 6. Break down 6, you get 2 times 3. Okay, then 4 is times 2 times 2, because 4 is 2 times 2. 2 times 3 is 6. Everything will be raised to the power of b. Then your 9 is 3 times 3 times your 6 is 2 times 3. Okay, then from here, check it very well. You see that 2 is appearing 3 times. Can you see that? 2, 2, 2. So you have 2 raised to the power 3. Sorry about that. Let me create a little space. So 2 is appearing 3 times. 1, 2, 3. So you have 2 raised to the power 3 times 3 is appearing once. So you have 3. Everything should be raised to the power b. It's equals to, yeah, 3 is appearing 3 times. 1, 2, 3. So you have 3 raised to the power 3 times 2 is appearing once. So 2 raised to the power 1. Then from here, this b affects everything in the powers, everything in the brackets. So you have 3 times b, that will give you 3b. And imaginary one is here, don't forget. So you have 2 raised to the power 3 times b, that will give you 3b times 3 raised to the power 1 is here, don't forget. 1 times b will give you b. 3 raised to the power b equals to, here you have 3 raised to the power 3 times 2 raised to the power 1. Then you need to make the right hand side to be equals to 1. Everything here should be equals to 1. Should be equals to 1, okay? Now let's make everything here to be equals to 1. So we divide both sides by this same value. So we divide both sides by this same value. Divide both sides by that. So that will give you 3 raised to the power 3 times 2 raised to the power 1. Hope you are following. Follow up. Let's go. Now, the right hand side, you do the same thing. Sorry, to the left hand side, do the same thing on the left hand side. So you have divided by 3 raised to the power 3 times 2 raised to the power 1. So everything here will give you 1. Okay, now let's deal with the left hand side. Now apply your law of indices here. This is 2 and this is 2. You are doing division. When you are doing division, you should be doing minus. Division is minus in indices. So since this is division, you are doing minus and the base is the same, 2, 2. So subtract the powers, that will be 3b minus 1. So you have 2 at the top here. So you have 3b minus 1 times, then you have 3, the power is b. The power here is 3, the power here is b. So this one will be 3b minus 3. Division is minus, so b minus 3. Everything will be equals to 1. So these two answers, this answer now will now be paired with the second answer. Okay, now we have the two answers side by side. You can see the two answers. This is the first one, this is the second one. So we pair them together. Since both of them are equals to 1, that means they should have the same value. Since both are equals to 1, that means they should have the same value. So let's just pair them together. Let me write this one first. I'm going to write this one first. That will be 2 raised to the power 2a minus 1 times 3 raised to the power a minus 2 equals to, then I'll write this one. I'll write this one now. So I have so I have 2. I'm writing this one now. 2 raised to the power 3b minus 1 times 3 raised to the power b minus 3. Okay, now since this is a base, both sides are equal, so that means the power should be the same. The power here of this 2 should be equal to the power of this 2. The power of this 3 should be equal to the power of this. So we pair them together. So let's equate these 2 together. This one. So we are equating this one and this one together. So that will give you, if you do that, you get 2a minus 1 is equals to 3b minus 1. That's the first equation. Then the second equation, we are pairing this one together. This 3, this one for the power of 3, and this one. So you pair them together. So that will give you a minus 2. A minus 2 is equals to b minus 3. So you just need to rearrange it. You need to rearrange it. It looks like simultaneous equation. You need to rearrange it. Okay, you need to rearrange it. So to rearrange it, you have 2a here. Let's rearrange this first one. I'm rearranging this one first. So you have 2a. Let's bring this b to this side. Let's bring this b here. Then we'll bring this 1 to this other side. So if we're doing that, we get 2a. 2a is already here, so you write 2a. This b is coming here, so that will be minus 3b is equals to minus 1 is already here, so you write minus 1. This minus 1 is coming to this side, so the side will become plus. So at the end of the day, you have 2a minus 3b is equals to 0. Okay, let's call this one equation 2. This one will be equation 3. Then let's arrange for the second one too. If you do that for the second one, you get something like this. This a is already here, so we are bringing this b to this side. Okay, so let's bring this b to this side and take this 2 to this other side here. So if you do that, you get a is already here. You're bringing this b, that will give you a minus b is equals to minus 3 is already here, so you have minus 3. This 2 is coming back here, that will be plus. So that will give you a minus b is equals to minus 1. So this one is equation 4. So these equations will now be solved. This one, this equation, and this equation. You can actually solve it from here, but I'm trying to make it easier, so that's why I simplified it like this. So let's go to the final solution now. So you have to solve these 2 equations simultaneously. So let me just write them out. So you have 2a minus 3b is equals to 0. Then you have a minus b is equals to minus 1. So if you use simultaneous equation, depending on the method you want to use, let's just use elimination method. So I'm multiplying, there's imaginary 1 here and there's 2 here. So I'm multiplying this equation by 1. Then this 2, I'm going to multiply this equation. So I'm multiplying this one by 2. So if you do that, you get, if you multiply everything here by 1, you get that same thing. So 1 times 2a, you still get that same thing. So you have 2a minus 3b is equals to 0. Then I'm multiplying everything here by 2. So 2 times a, 2a, minus 2 times b, 2b. 2 times minus 1, minus 2. So then I'm going to subtract. So I'll subtract 2a minus 2a. So 2a minus 2a, that will give you 0. Okay? 2a minus 2a is 0. So everything here is 0. You don't need to write it because it's 0. Then you have minus 3b, minus 3b, minus then minus 2b. It's equals to 0 minus minus 2. 0 minus minus 2. So this one will give minus 3b. This one is plus 2b. It's equals to 0. This one is plus. This one becomes plus. Minus times minus is plus. So 0 plus 2. 2. Minus 3b plus 2b will give you minus b is equals to 2. Then from here, b is equals to minus 2. So this is the answer for b. Don't forget, you still have to find a. Now let's look for a. Now if you look for a, we have gotten b as minus 2. All you need to do is come to any of these equations. Maybe go to any of these equations above here and just substitute the value. Don't forget a minus b is equals to minus 1. That's the relationship between a and b. You can use any of the equations. You can even use maybe equation 1, 2, 3, or 4. But let's just use this simpler one. A minus b is equals to 1. That's the relationship between a and b. A minus b is equals to minus 1. A minus b is equals to minus 1. So let's do that now. So a minus b is equals to minus 1. That's the relationship between a and b. So we have a minus b is equals to minus 1. So we'll put this value inside here. So we have a, this is b, we have minus, then this is b, so minus 2. Okay, it's equals to minus 1. This one will give you a plus 2 is equals to minus 1. Then from here, you have a equals to then from here you have a is equals to, take this 2 to this side, minus 1 minus 2. So a is minus 3. So we now have the value of a and b. Now, but this is not the final answer. You have to go and substitute it into the the expression you were given. You were given an expression from the beginning. So you need to go and substitute there. Now that expression, sorry about that. That expression is ab. You need to substitute into ab plus 5 into a minus b. I'm trying to find the value of this expression here. And you usually have the value of a and b. So you have b, your b is minus 2 and your a is minus 3. So just substitute there. So if you do that, you have a is minus 3, b is minus 2, plus 5 into a is minus 3, minus b is minus 2. So you have another minus 2 here. So take note of your signs, because a is minus 3, then there's a minus here, this is a minus, but the value of b itself is minus 2. So you have to have minus 2 there. So this one will give you 6. So this is 6 plus 5 into, you have minus 3. This 2 is will give you 1. Minus is plus. Minus is plus. So you have minus 3 plus 2. So if you finish that up, that will give you 6 plus 5 into minus 3 plus 2 is minus 1. So that will be 6. 5 times minus 1 is minus 5. So 1. So the value of that expression is 1. Okay, the value is 1. The value is 1. So if you enjoy our channel, please like and subscribe. Okay, like and subscribe. The channel is EduMaths on YouTube. Like and subscribe so you can have more videos like this. The subscription keeps us going. Okay, thank you for watching. Hope you understand. If you don't understand any aspect, you can indicate it in the comments below. Okay, so I can attend to you guys. Okay, thank you for watching. Remain blessed. Bye.